In this video, we're gonna just go through the exercise, week 4 exercises, and just answer a few questions you might have. The first exercise I think is quite straightforward. Just create this hierarchy. It's all about getting used to visual paradigm. There is no right or wrong answer. All you have to do is just get your few classes, um, shape 2D, so on and so forth. Shape 2D. Um, you can get that's too big. Just you can or just add a class. Let's just look at the names: elliptical, polygon. All you need to do is just create this and then elliptical polygon. Okay, so just also put the return. You can select any item type. Sorry. So for the members, you can just select any return type. You can add any parameters. All I want you to know is just get familiar with this. For example, let's just add attribute center. You can even say this is a type point. For example, you can even in that case you can create a class called point. Oh no, not this one. I'm not interested in point 2D. You can say that something like this, or just point. Let's just say point 2D. Even if you want, you can just go a little wild. Just create X and Y attributes: X integer, Y integer. There we go. Now we are actually, for example, you can show realize, but show dependencies. No, this one. Why does it show? Oh yeah, show dependencies from here. Not associations. That's fine. Oh yeah. Oh, okay. Sorry. Not dependency. Of course, it's an association. That's why it doesn't show as a dependency. As you can see now, the dependency, because there is. I actually put this. This is recognized as an association. Let's just do some generalizations. Elliptical. You can do other things like you can put integer, whatever you want. The types and for example, let's say operation. What are some of operations? Get center, translate. Clicking the wrong item. Get center, for example, it will return a point 2D because, of course, get center. For example, add. Let's just add another operation. Translate. That does not return anything. As long as it's semi logical, it's fine, guys. The whole point is for you to get used to using all these specification. For example, how you enter attributes, how you look at the operations and get the operation specifications. Get center, for example, it returns point 2D type. These are not important in and out. Oh, sorry. These are for C. C++, lower upper body condition. These are not really important. You can look into parameters. You can add parameters. For example, there's no parameters on this one, but you can add parameters. For example, let's just add, what can we add? Get area, get scale, get bounding, change scale, for example. Let's just say add it's a shape 2D. Let's add an operation called move. We can pass a p point which returns doesn't return anything. For example, it moves this by giving the center by giving this point. So it's a 2D, there's a center, so it moves the center of the, for example, you can even do things like that. That's fine. It's just for you to get used to all the elements. So the generalization, realization, other things you can, if you want, for example, you can have an interface. Let's just do, you can create an interface, for example, drawable. For example, you can have, and then you can just add an operation called draw, which does not, which returns, for example, boolean. You can say, and then let's just say all the shapes are. Let's just realize this. The shapes are 2D. All the shapes are, for example, realize as drawable. This is fine, guys. You can do it however you like. As you can see, this was actually today we talked about this on Tuesday's lecture, that unidirectional. As I actually see that it's actually picked up. It is a unidirectional, and the role is center. As you can see, the variable name is center. It just put the variable name, just the role name is center. This is quite nicely. This is quite nice actually example of association, and because it's one-to-one, it didn't actually go with the visual paradigm, did not actually create the variables, the numbers, because it's just one-to-one. You can just create some hierarchy, just create a hierarchy that makes sense. You can, for example, make them, as you can see, these are, for example, you can make the classes abstract classes. For example, I can make this open specification. I can make this an abstract. It doesn't matter as long as you don't make the abstract. As you can see, some of them. This is, for example, abstract, abstract, abstract. I think abstract because they're italicized, and these are not abstract. As you can see, it's very hard to see, but if you look closely, you will realize that these are italicized. It's not the easiest thing to see, but this is more like it. You can see it clearly. This is italicized, so this is an abstract class. You can say that. So this is an abstract class. So it's up to you guys. You can do whatever you want, as long as don't select the latest version. These shouldn't be abstract, of course, because these are the objects that you actually create. So these you create the instances of these classes. Don't make them abstract, but usually the top ones might be quite. They might be abstract. They might not be abstract. It's up to you guys. So this is the first exercise, and we have a second exercise, which is actually I'm going to spend a lot more time on. The exercises here, you start by cloning this code. You can do it in different ways. For example, one way might be just using the NetBeans git clone tutorial. You can do this by git clone, or you can just go to, let me just do this. For example, let me just create a folder. I have created a lot of tests apparently. cd test. I can just create a test. Test, and then test. There's nothing in here. You can do git clone, and then let's just copy this, copy the clipboard, and then let me just, oh no, why do this funny thing is going on? example, git clone. You can actually clone the GitHub. This way, authentication failed. If I'm not mistaken, oh, again we made a mistake, but it's okay. Once, okay, it's unpacking object, that's fine. You can actually create, you can follow this, and then you can create a new project, and then you can add them into your project, or you can just follow, you can create a new project from existing sources. You can go next, and then you can select existing, you can just name it, you can select as your folders and test packages. I think they were under documents. Were they in documents? I thought they was in documents. Home. Oh no, sorry. It was under home. There should be a test. Yeah, they're under test lab 1. Source, for example, I can select the source files here. I can add the test files from there. Next, I can just include everything. As you can see, it will just copy everything in there, so on and so forth. And then you will end up with you should end up something like this. If I'm okay, lab 1 modularity. I think this is what it should look like. You should have something like this. Procedural. There you go. That's the procedural one. There's the item and cost, so on and so forth. So it should look like this when you download it. Okay, the first one is I think that's the procedural. I mean, in terms of procedural, what you need to do is, of course, all you can do is just create procedural functions in Java. So you can just divide this whole big, unbelievably long code. You can just break it into more modular functions, so that every time you call a function, you can actually, instead of just having a big if analysis, you can just divide this, and then people actually call these codes rather than the functions, rather than just calling the one, as they say, top function, like above all function. This one that actually does everything. So you should avoid doing this rather than this. We can actually divide it into different ones. As you can see, we take let's just move this in here. Okay, so instead of all these switch cases and just multiple options, we just create functions for everything, and then just divide them into all the functionality into a nicely followable. As you can see, it's really hard to follow all of this. What's this break? Read John's JSON. Why are they? But if you look at this, where is read from XML, where is read from JSON, is very simple. This is just to remind you what would it be if you want to write something procedural. Okay, let's actually look at the solution in object-oriented programming. This is the important part. So you can find the solutions. I've actually given you the solutions on QM+. QM+, you will find the Git repositories for these two solutions. You can copy them, you can clone the repositories, and you can look at the solution. Now I'm going to go through this solution in order to give you some idea of what the solution look like. So the object-oriented one looks like this. So there's there's a book that actually doesn't really read and write. There is a item, and there is also some class that actually calls this for reading and writing. You can actually copy them from here in order to read and write to book, cost, book and magazine, types of item, and cost is actually is auto-generated from the XML. So these are all auto-generated, so you're not supposed to change this because the XML tags are actually based on that structure. So it wouldn't work if you change anything. Reading, writing XML and CSV might not work, and JSON. Okay, so the solution, the first solution is something like this. Okay, so what have we done in here? As you can see, this is very close to one of this solution is not very close actually. This solution is an example of open close principle. So as you can see now, we moved all the operations, all the behavior to the item interface. So now the item interface define save as XML, save as CSV, which is common to all types of item. So they can read from an XML, CSV, or a JSON file. They can also save themselves. Each magazine, each book can actually serialize themselves or save themselves as JSON, CSV, or XML. So reading and writing or saving, all implemented, all used by an interface. So what does this Java interface do? If we go to the solution, for example, this is the Java interface file. So this acts, as we discussed in the lecture, this acts as a contract between all these item types and the class Java that actually uses it. So we know that every item type can read and write to different types of files. So we're just saying that no matter what item type we provide, it will be able to save as XML, CSV, JSON, and read that as XML, CSV, and JSON. So once we do this, let's just go back to this. Once we do this, now all magazine and book has to actually provide all these three read and write operations. So as you can see, read and write can actually each item has to implement it because they're all abstract functions, because they're realizing it, so they have to have their own implementation. So this is let's just have a look at the book. So as you can see, book has the same as we just copy and pasted from the procedural file. It just does pretty much everything that the procedural does. You can just save it and write it. So as you can see, save it as just string file name. You just pass the file name to everything, all of them. So it already knows the type. All you have to do is they just convert it into a book or a JSON or some other thing. We actually created a hash function and equals function in order to check equals and which allows us to do certain things. For example, check if a book is equal to another book. You can actually check by the hash function and equals function. So for example, we implemented a custom equals function which checks if the ISBN content of the given book is equal to this book. Then it is the books are the same. So that's how it is in real life, is it? The same books have the same ISBN. You don't have to check the object type. You're not just checking if the given two objects are actually the same. It might not be the same. You might have different books, but if they are the same book, instead of in terms of in real life, the book equality comes from if the ISBNs are the same, they are the same book. So you can implement something like this. If we go back to the solution, okay, so if you look at this now, after having each interface, actually each item having all these functions, now my sum class, which has a dependency on it, can be implemented as implemented very simply. So the good thing is now I can actually implement this class as a closed in terms of reading and writing to CSVs. For example, in order to write to CSV, I can just say read from CSV. I can just pass the item type, and then I can just say that, oh, okay, this is a book item, read it from this file. This is a book item. This, for example, I can just say this is whatever item type is. I can pass it to it, and then I can just say that save it to this file. So as you can see, no matter how many different types of items I add, these all these functions will still stay the same, because it is based on the item's ability to perform these. And how do we guarantee this? Each item is going to do it. Each item has to realize this interface. So as soon as they realize this interface, because these methods are abstract, they have to implement these behavior for the type of the item they are. So, for example, if I add a new movie, magazine, new movies, or any other items that you can find in a library, then I can actually add that item type. I will have all the items will have save as XML, save as CSV, as JSON for that specific item type. So as you can see, it doesn't matter. So now I can extend the items. I can add any more items in here. So I can extend the item, but it is open for extension. But at the same time, because in order to add, all I have to do is just create the new class and then realize the item interface, and then just implement those implementation without changing anything to any other part of the code. At the same time, some class will not be affected by it can be extended, the some class, because you can add new functionality to this code, to the new items, so this will affect the some class. But at the same time, you don't have to make any changes, because all these are actually based on the interface design. So now it's closed for closed for changes. Some class closed for changes, but it's also open for extension, because you can add new items without changing any code. So this is the simple open close answer to the question. I also provided a little bit more advanced solution. Let's just have a look at the solution, which is the number 2. If you look at this, there's actually a persistence package. There's a persistence package which actually includes a format handler interface. This is an interface. Let's just close all of this. And so there is some addition to it, which includes, which separates the writer types from the items, and then it makes the extendable part just a little further. So it is slightly different, as you can see in here. What we do is we actually separate the saving and the item types from the books. What we do is we actually create a new type of format handler which reads a book, save a book, read a magazine, save a magazine. So basically this is done by having a format handler. Of course, when you add a new item, you have to modify if you add a new type, you have to, if you add a new item type in here, you have to modify the format handler. That's the only change that you have to do. But also in here, you can add another type of persistence handler, for example, CSV, JSON, XML. You can add a database. You can have regular text file, save it as text, save it as persistent, save as I don't know, save as a memory dump, so on and so forth. You can do all of these things. We also have an enumeration type that defines in order to make this more extendable based on some class. This will allow you to add, also extend new handlers or new savers. So this is another solution. You can have a look at the for example, we can look at the source. So each of them have save book, read magazine, save magazine. based on, of course, these two. If you have more, you have to add more types of items in here. Unfortunately, it's not. This part is not very. The at the end, this part is extendable to a certain extent, but it's of course the changes from the object parts will of course affect this part. So every time you add a new object, you have to add the code that reads and writes that object type. But other than that, we this actually makes the sum class to an extent a bit more flexible. So now all I can write is read or save. Then I have to type. I can just say that this is the item, this is the file, and I want to save it as this file type. Now all I have to do is item read or write, and then I can just say that file name this, type this. So this is a bit more extendable. It's just rather than separating. Of course, you can do a similar thing with this, but this comes because this also comes from the ability to actually read and save. This is more because I'm using a handler factory, regardless of the type, file type that actually passed to it. We'll talk about this next week. It's a design pattern, so factory design pattern. So I'm getting different types of handlers. So based on the type that I pass, there's an based on this interface type, I'm creating a new handler for each of them. So this format handler factory actually returns either one of these types. So as you can see, if it's in CSV, it's returning a CSV handler. If it's a JSON, if it's an XML, it returns an XML type. So all I have to do is, for example, if the type is XML, this will return an XML type. So XML handler dot save book will be called at the runtime. XML handler save book is called, and then is it save book? Yeah, save book is called, and then it just saves the given book item to the given file. So as you can see, a simple usage of two different solutions. One is slightly more advanced compared to the other one, but here is a solution that uses open close principle to different ways and makes the code. As you can see, the improvements of the code we came from, we started as just a where's the class procedural. We started as this, and then we turned it into, we started with this code, which is terribly written. It's just a big mess. You can't extend anything, do much with it. Then we created some objects, and then we made it a little object-oriented code by using a small some way of object-oriented programming. As you can see, we just created this. Then we can actually we improved our solution slightly differently, and then we ended up something a lot more I think this is a lot more flexible and modular design. As you can see, we separated everything, although some people might disagree because this is actually have to do with the this is just a design decision. Some people might disagree that everything that has to do with the book has to be in the book, but this is also another way of solving this problem. In a way, this is more extendable, more open to changes. So I hope that you find this explanation and the video useful to explain what what these solutions actually mean. And I hope that you learned some basics of design, especially in the application part, how you get from very basic maybe design, and how you can improve it by learning certain design patterns like handle factory or other things. So we'll have more examples of coding, especially when we talk about design patterns next week, and hopefully you will learn new ways to improve the code that you write. So I'll see you in the next video.